All right, so in this video, this is going to be the last exponent skill you learn this week, and there's really only one more after this. But in this one, we're learning how to raise a power. So something like 8 to the power of 4, that whole piece there is called a power. So it's raising a power to another power. So what this would look like here is if you have 8 to the power of 4 squared, we know that whatever's in the parentheses is our base, and our exponent tells you how many times you need it. So that would be 8 to the power of 4 times 8 to the power of 4, because this too would tell me I need two 8 to the power of 4s. Well, when I put that together, I get 8 to the 4 plus 4, which is 8 to the power of 8. So we're going to expand each one of these, and then we're going to see that there's a way that we actually can simplify this. So what we have here is we have a base inside our parentheses. It tells us we're taking 5 to the third, and we are multiplying that 5 times. So this is really 5 to the third times 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 5 to the third. That's 1, 2, 3, 4, 5. Because this 5 here tells me I need 5 to the thirds. So now if we think back to our rule from 2 days ago, we know that when we have like bases, what we do is we add the exponents. So 3 plus 3 plus 3 plus 3 plus 3 is going to give us 15. So this is 5 to the power of 15. And if you look at these two numbers here and the solution, and you look at these two numbers here and the solution, you might start to figure out what's going on here. Notice the base stayed the same the entire time. All right, so in the next one here, it's telling us we're taking negative 3 to the third power, and we need that base twice. So this is going to be negative 3 to the third power the first time, and then negative 3 to the third power the second time. So again, this exponent of 2 tells me that I need 2 of the negative 3 to the thirds. So if I use my rule from yesterday, when my base is the same, I keep the base, and when I'm multiplying, I add the exponents, and 3 plus 3 is going to give me 6. So I end up with, oops, didn't mean to end up with that. I end up with negative 3 to the power of 6. And negative 3 to the power of 6. Again, we don't have to simplify something that has an exponent that's bigger than summer math, so bigger than a 3. So in this one, when we have an exponent, again, this is saying that we have, and this is simply what we did the other day, we have 3/4 3 times. But what we really have here is 3 to the first and 4 to the first 3 times. So this is 3 to the first over 4 to the first times 3 to the first over 4 to the first times 3 to the first over 4 to the first, because it tells us that we need to be thinking about 3 of whatever this base is, 3/4. So here our base is going to stay the same, which is well, we actually have two bases here. We have one in the numerator and one in the denominator. So our numerator base is going to stay the same as a 3, but now it's 1 plus 1 plus 1, so it's 3 to the third. And then my denominator base is going to stay the same. It's 4, and then 4 plus 4 plus 4, or excuse me, 1 plus 1 plus 1 is equal to 3. Now on this one, it might be 3 to the third over 4 to the third, but since these are cubes, this is potentially, since that's a summer math fact, I could give the answer as 3 to the third, which is 27, over 4 to the third, which is 64. So again, here we had exponents of 1 raised to the third, 1 raised to the third, and we ended up with those 3's there. So again, some of you might be seeing the pattern. So right now we end up with negative 2/5, and each one of these is to the first power, and I end up needing that 4 times. So that's the second time. And the fourth time here. So now, again, I've got a base in the numerator and the denominator. So I've got in parentheses here, I've got my -2 being raised to the power of 1, 2, 3, 4. And again, that negative has to be inside of parentheses there. And then you can keep that in the numerator, since I guess we don't need to have the whole thing in parentheses. We just need to make sure that the negative piece stays inside of parentheses. And then this is going to be 5 to the 4th. So really, you end up with -2 to the 4th over 5 to the 4th. And that negative could be out front, it could be on the top, but like it's the whole thing is negative. It doesn't specifically belong to the 2 at that point. All right, so again, here we had 2 to the 1st over 5 to the 1st, and we ended up with exponents of 4. So the power to a power rule, and again, the power to a power rule only exists when you have an exponent and another exponent right there being multiplied, like that it's being raised to. This does not mean that you just multiply everything with your now. This is a very specific property. So we're going to continue along here, and I'm going to tell you what this rule is. So if we're looking here, you're going to see that we have our powers here were 3 and 5, and we ended up with 15. Well, what is 3 times 5? It is 15. Here we had 3 cube raised to the second power, and we ended up with a 6. Well, what is 3 times 2? It is 6. Here we had 3 to the 1st and 4 to the 1st. What is 1 times 3? It's 3. And 3 times 1 is still 3. So the power to a power rule tells you that when you raise a power, and that means an exponent, to another exponent, you multiply the exponents. So now, rather than having to take something like 6 to the 5th and writing it out as 6 to the 5th times 6 to the 5th times 6 to the 5th and doing 5 plus 5 plus 5, our power to a power rule tells us that when we have an exponent being raised to another exponent, we can just multiply. So this one would give us 6 to the power of 5 times 3, so 6 to the power of 15. Looking at this next one here, I have 5 to the power of 8 raised to the power of 2. So again, this is power to a power rule, so I multiply. That would be 5 to the 8 times 2, which is 16. Now these next ones here get a little bit more complicated because we have the power to a power rule, but then we also have multiplying with like bases. So this one is going to put together the two rules that we've been working on as this week has gone through. So in this one, anytime I think about order of operations, exponents comes early, but what comes before exponents is parentheses. So when I come to this situation, I see all these exponents, but I also see parentheses. So that's an indication to me that I want to start with the parentheses here. So I want to start with my 3 to the 2nd power being raised to the 3rd power. And how I do that is my power to a power rule, so I multiply. So what I have here is I still have 3 squared, but now it's being multiplied by 3 to the power of, well, my power to a power rule says 2 times 3, so this is 3 to the power of 6. Well, now we have to use our other rule because we have 3 squared times 3 to the 6th. And when we are multiplying with like bases here, we add our exponents. So when I look here, this is going to be 3 to the power of 2 plus 6, which is 8. All right, let's look at the next one. So the next one, we want to be careful because anytime we see a base without an exponent on it, we want to add it in. So we have 6 here to the power of 1. And again, that's going to be important because after we deal with our power to a power rule, we have to deal with our like basis rule. So it's important that we know that there's a 1 there. So here I have 6 to the 5th power, and that's being raised to the 3rd power. So I use power to a power here, and 5 times 3 is 15. So this is 6 to the power of 15 multiplied by 6 to the power of 1. Well, in a situation like this, again, we know that we have like bases. And again, I'm not raising an exponent to another exponent. I'm just multiplying like bases together. So now I have my 15 and my 1. So I add my exponents, and this becomes 6 to the power of 16. All right. So we're going to work on this next one here. And the next type of problem only ever upsets people because really there's two ways to do it. So I'm going to show you just one of them because it is the easier way to do it, and it's the one that I want you to use. So when we have order of operations here, P, E, M, D, so we look here and you're like, wow, there's a whole lot of weird parentheses here. So what we have here is brackets, and then we have parentheses. So when you're dealing with brackets and parentheses, you want to start sort of at the innermost parentheses. So we want to start with this situation here. Now, this is where people sometimes get confused because here, do you see we have all these parentheses? So people are like, oh, I'm going to multiply because I see parentheses, 9 times 2. No, because here, this is just saying 8 squared multiplied by 8 to the ninth. This is not the second being raised to any power. This is not the ninth being raised to any power. Right in here, this is the exact same thing as saying 8 squared times 8 to the ninth raised to the 3rd power. And what they did is they used the parentheses instead of the dot for the multiplication symbol just to confuse you, to make sure you know that I'm not raising a power to a power in there. That's just normal multiplication. So when we look at it like this, it becomes pretty simple. I look in the inside here and I know it's 8 squared times 8 to the ninth. Well, I've got like bases and I'm multiplying, so I add. So that's 2 plus 9. So this is 8 to the power of 11. Well, now I have 8 to the power of 11, and that is being raised to the 3rd power. So at this point, I can use my power to a power rule, and that tells me that I take whatever power and I multiply by whatever power it's being raised to. So I'm going to have 8 to the 11 times 3. So I'm going to have 8 to the power of 33. So those are the types of problems that we're going to be seeing. We're going to go through and do a couple more. But again, the only part of your math work for today is to watch this video. Then tomorrow you have a little Canvas skill check on making sure you can use these rules. The questions, I literally made them while I was looking at this document. So if you've watched this and you understand this or you get confused, you can go back and look at this video. But again, the only math work today is to continue to go through the rest of the questions in this video. So we're going to make it. All right, so they start to get a tiny bit more complicated here, but it's going to be the exact same concept. So when I look here at this first question, I start this one here on the left, and I see that I have 4 to the 4 squared raised to a power, and then I have 6 cubed raised to another power. So again, I have to start with the power to a power rule, because anytime really you see an exponent right next to another exponent like that, that's going to be an indication to you to use power to a power. So to start this problem, I have to use power to a power here, and then I have to use power to a power here. So I end up with 4 to the power of 2 times 4, which is 8. So I end up with 4 to the power of 8 multiplied by 6 to the power of 3 times 3. So 6 to the power of 9. Now, we have to think about our exponent rules. Can I combine these? Can I do 6 times 4 is 24 to the power of something? No, I cannot, because I can only combine or multiply situations where we have like bases. So in this situation, when I have 4 to the power of 8 times 6 to the power of 9, I can't do anything else here. This is considered fully simplified. So that would be the answer that would appear in Canvas, because that one can't be simplified anymore. We'll get to one like this, where after we do power to a power, there's another little step. All right, so this next one here, don't get confused just because you see a negative. It's the exact same thing. So here I have 3 to the power of 3. That's fine. I don't have any parentheses there. I'm going to let that go for a second. I come here. I have 3 to the power of negative 1, and it's being squared. So I know often, or when I see a negative, I'm supposed to think about turning it into a fraction. But what I want to think about first is, can I use it? Because I don't want to think about turning it into a fraction sort of until that last step. So if I use my power to a power rule, I can use that with negatives as well. So I end up with 3 to the third power multiplied by 3 to the power of negative 1 times 2. So 3 to the power of negative 2. So now I've got like bases here, and all I have to do to multiply like bases is to add my exponents. So this is 3 to the power of, well, I have positive 3 plus negative 2. Positive 3 plus negative 2 is 1, and 3 to the power of 1 is just 3. So I hope this is making sense as we go through these, but we're going to keep going here. We don't have that many more. All right, so I want to add my exponent here. I have 2 to the first power over 3 to the first power. So again, these are just two different bases, a base in the numerator and a base in the denominator. I encourage you to think about it that way rather than thinking about it as a fraction. It's just a numerator base and a denominator base. So here, when I apply my power to a power rule, just like is typical in math, if I do it to one thing, I have to do it to both things, like the distributive property. I can't just distribute to one of them. I need to distribute to both. Since I have two bases, so I need to take 2 and I need to do 2 to the power of 1 times 4. And then I'm going to do 3 to the power of 1 times 4. So this is going to be 2. Well, 1 times 4 is 4. So I have 2 to the 4th over, well, here I have 3 to the 1st, and 1 times 4 is still 4. So this becomes 2 to the 4th over 3 to the 4th. And that there would be your final answer because you have different bases, so you can't do anything else here. All right, so we're going to look at this next set here. And in this next set, we have several different instances of the power to a power rule, and then we're going to analyze what we have left. So I'm going to start here. That's going to be 4 to the 3 times 2, so that's going to be 4 to the power of 6. Then I'm going to have 5 to the power of 2 times 3. Well, 2 times 3 is the same as 3 times 2, so that's going to be times 5 to the power of 6. Well, now I have 4 to the 4 times 2, so that's going to be times 4 to the power of 8. And then I have 5 again to the 3 times 2, so that's going to be 5 to the power of 6. So after we did our power to a power rule in this first question, we're done. But when I go look at this next problem now, I actually see that I have two problems here. I have 4 to the 6th and 4 to the 8th. So when I put these together here, this becomes 4 to the power of, well, 6 plus 8 here is actually 14. So this is 4 to the power of 14. And then I'm going to be taking that, and I know that I can combine my base 5, 6 with my base 5, 6 here. So I can multiply 5 to the 6th times 5 to the 6th. And when I add those exponents there, I end up with 5 to the 6 plus 6, which is 12. So again, the important thing to remember is when you have the exponent right next to another exponent, you have parentheses connecting an exponent to an exponent directly, that is always going to indicate to you that you are going to multiply. All right. So in the next problem here, we are going to be looking at a situation where, again, these are almost exactly like the ones that we've just done. And then underneath that, those are again just like the ones that we've just done. So we're just looking at another set. So depending on your comfort level, what you might want to do now is just pause, and you might want to try to do these 1, 2, 3, 4, 5 problems, and then check your answer. I'm still going to go through them step by step. So if you want to just pause and work these out and then check, that's absolutely fine. But then please do go through and check, and then you can fast forward through the explanation to check your answers. But then if you get one wrong, you need to go back and actually look at how that happened. But I'm going to go through these faster this time. All right. So what we're going to do here is we've got 7 to the power of 5 times 3. So when I put that together there, that is going to be 7 to the power of 15. So 5 times 3 there is 15, so that's 7 to the power of 15. In the next question here, we have 8 to the power of 8 times 2, because again, I just have a base raised to an exponent, so 8 to the power of 8 times 2 is going to be 8 to the power of 16. So we're going to move on to the next one here. And in the next one, I have 2 squared multiplied by 2 to the 4th raised to the 3rd power. So when I have 2 to the 4th raised to the 3rd power, I want to start with my power to a power rule before doing my multiplying like bases rule. So when I take 2 to the power of 4 times 3, this is 2 to the 2nd power multiplied by 2 to the 4 times 3, which is 2 to the 12th power. So this is going to become 2 to the power of 2 plus 12, so 2 to the power of 14. We go to the next one, and this is, again, you have to be extremely careful when you have a number that looks like it doesn't have a base, because it does, or an exponent. This is 9 to the power of 1, which matters when we have to add to combine like bases at the end. So here I have 9 to the power of 5 being raised to the 3rd power. So again, I start with power to a power there. So this becomes 9 raised to the power of 5 times 3. So that becomes 9 raised to the power of 15 times 9 raised to the 1st power. So that is going to become 9 raised to the power of 16. All right. So as we continue on here, we have our problem that's designed to confuse you. If you look here, you might be tempted to multiply, but the only way that you would multiply is if the 7 was right there, right next to it, where you could just like draw a little connecting and they're there. You cannot connect those like a nice little ring there, so you cannot multiply them. This is multiplying like bases. So this is actually 5 to the 3rd power times 5 to the 7th power raised to the 3rd power. So what I want to do here is I want to simplify by multiplying like bases before I raise to that power here. So this is actually 3 plus 7. So this is 5 to the power of 10, and that is being raised to the 3rd power. Well, now I'm left with my power to a power rule. So I'm going to take my 10 and I'm raising that right there to the 3rd power. So that becomes 5 to the power of 30. All right, so we are almost done. And then again, that's it for today. You learned your lesson of what we're working on. And then tomorrow you'll do a Canvas quiz. I think it's 11 questions, and they're just like these ones. Some of them are as simple as the first one. They're all multiple choice, and they all look exactly like one of these problems. So if you watch this video, it will be very, very obvious as you work through that work. All right, so right here we have 5 squared raised to the power of 4, and then this is actually 7 to the 1st power here, raised to the power of 3. So I'm going to multiply like bases here, and this is 5, well 2 times 4 is 8, multiplied by 7 to the 1 times 3, so that's going to be 3, so that's going to be 7 to the power of 3. So 5 to the 8 times 7 to the power of 3. All right, and this next one here, I have 6 to the power of 7, multiply, well, here's my power to a power, so I want to start by multiplying my powers here. So I have 6 to the power of 7 multiplied by 6 to the power of negative 2. Well, again, you can still add positives and negatives. All you're doing is combining like bases here. So this is going to be 6 to the power of 7 plus negative 2. Well, 7 plus negative 2 is 5. So this is 6 to the power of 5. We're going to move along to our next problem here, which is 5 to the power of 7 and 6 to the power of 7. Again, this is just a numerator base and a denominator base. So when I work through these problems here, I'm going to take my 7 to the power of 1, or my 1, multiply it by 7. I'm going to take my 1 here, multiply it by 7. So I end up with 5 to the power of 7 over 6 to the power of 7. And your final problem for today is you're going to look here and we're going to have 4 instances of combining like bases, or power to a power, excuse me. So this is 9 to the power of 3 times 2, which is 6, times 5 to the power of 2 times 5, which is 10, times 9 to the power of 2 times 2, which is 4, and then 5 to the power of 3 times 2, which is 6. Sorry, I got excited about the 6. So that's 5 to the power of 6. So now I've got 2 base 9s, so those can be combined, and I've got 2 base 10s, so those can be combined. And when we combine them, we're multiplying. So this is saying base 9, 9 to the power of 6 times 9 to the power of 4. So that's 9 to the power of 6 plus 4. So that's 9 to the power of 10 multiplied by, well, my base is 5. And when I multiply like bases, I'm just adding. So that's 10 plus 6. So that's 5 to the power of 16. So that is it in terms of your lesson for today. So thank you for getting that done. And the lesson for tomorrow, so Friday's work, is to go into Canvas, and it should be right here. So we're going to go into Canvas, and for Friday, this was the video you just watched, instructional video and exponent rules, power to a power. Now you're going to click power to a power exponent rules, and you're going to take that little 10-question quiz there. And again, if you look, oh, you can't look at it right now because I'm not connected to the internet. So oops, no preview. So at this point, we are going to be done. So just go ahead, turn this off. If you want to do your Friday work right now, knock it out. If you watch this video, it should take 5 to 7 minutes. But if you just go click random stuff, then it will not go well for you. So again, just take that either today or tomorrow. But other than that, you are done for the week. All right, bye guys.